Alright, welcome back to our video. Now, I forgot in the previous video to mention two other data types that are very important. These are the float and double. Alright, so these data types, we use them for numerical data with decimal points. Say for example, 1.5, 1.5, 1.9, 3.0, whatsoever, right? So to continue coding, let's just create another sets of codes for our main function. So by the way, you need to be careful once again where you're going to write your code. You should write everything inside your main function, and just above your return 0 for our return of our main function, right? So let's declare integer a, for example, and assign the data, numerical data here, number 5, and we should end our statement with semicolon. And how about the character? Then my character, and then for character data, it should always be enclosed with a single quote. So you can write any symbols here, but for this example, I'm going to write $sign and then end the statement with a semicolon. And next one, let's use float. For floating value, we can assign data that is having a decimal point. Let's say for example 5.9, like that. And also we can have double. Alright, so my double equals 1.9, something like that. So the difference between float and double is their size, because you need to know that whenever we declare a variable here, our compiler is going to allocate space for these variables, because these data we're going to manipulate in our program, they are going to be stored in the memory of our computer. That is for easy access for the operations of these data. Alright, for integer data, usually your memory will be allocated with up to 2 or 4 bytes of space, as well as for character, your memory will be allocated with 1 byte of data, and for float, your memory will be allocated with around 4 bytes, and for double, it's going to be 8 bytes. So let's just type it in the comment section, like 2 or 4 bytes here. For character, we have 1 byte, and for float we have 4 bytes, and then for double 8 bytes. So to check, to verify these, actually we can also call the functions to check the sizes of these variables. So we can also use printf later, right? So to check the sizes of these variables, we just need to use %lu, indicating long unsigned, and then comma, and then call the variable identifier of the variable. And we can do the same with our other data types, other variables, right? So what I have written here will help us see how many or how much is the size of this variable, right? So my float here and my double here. Alright, so let's just click. By the way, this is going to we're going to get not the appropriate output, so we need to use the Sizeof function and pass the identifier, by the way, of our function. Alright, I mean of our variable. So Sizeof, use the my char here. So once again, this we need to enclose this in a Sizeof function. So Sizeof function is one of the predefined function, just like printf, right? So this will help us get the intended size of our variables being declared with different data types. Okay, so click build and run. So we get by the way, let's put some spaces here. Return type, I mean escape sequence, oh my god. So click here. If you notice, everything gets concatenated, right? So we need to separate these with escape sequence. So we need to modify our printf here backslash n, slash n, backslash n, and then another backslash n. So let's click build and run once again. So alright, so here our integer, it uses 4 bytes, and for our character it uses 1 byte, and for float it uses 4 byte, and then your double, it uses 8 bytes. Alright, so that is how you check if there are certain situations actually wherein you're going to check how much is the space allocated for these or specific variables. So this function is very useful. Alright, so you can just take note of these. So this is not what I want actually, although it's part of the lessons, but this is not what I want. So let's just comment these out here. So if we comment these, that means they are not becoming the part of our compiler. They will not be read of by our compilers. By our compiler, I mean these statements here will not be read by our compilers. So let's click build and run. So we will get nothing in return, right? Because all of the printf functions are already commented out. Okay, so what we need to do is this time I want to display the data coming from these variables using printf function. So I just commented these to indicate that I have written functions wherein for us we can check the sizes of our variables. Okay, but this time I want to display as output the data being held by our variables. And once again, everything is written inside your main function. Okay, so you can use printf function still, and I want the data being held by this variable a to be displayed as an output in the console. So how to do it? I just need to use double quotes for the string data and write the prompt for our user to see. So the value of a is, and then since this variable is an integer variable, then we need to use %d. This is the placeholder we use to indicate that in the string an integer data will be displayed coming from the next parameter, which is a. A is the identifier of the variable we declared as int coming from this line number 7. So we can do the same, by the way, and do the same with other data types. So for character, we just need to change the identifier. My character is, and here %d, we change it to %c because this data type, I mean this variable, is being declared as character data type. And then we need to call the identifier mychar. Then next, the value of my float is, since it is float, we need to change it to %f, indicating that the data to be displayed is a float data. Right, and then the identifier my float. There you have it. And lastly, we have the my double. Right, and then % for double data, we need to use the long float, and of course we will change the identifier for the next parameter, which is my double. Alright, so it looks good. Let's click build and run. There you have it. As you can see, all of the outputs coming from the printf, they concatenated with each other. They combined in the single line, right? And this is not what I want. So to fix this one, we need to add the escape sequence -n, \n, I mean, to indicate that we're going to produce a new line right after a printf is being called. So here in this string, it is where at the end of the statement in the in the string, this is where we are going to put our \n, and another \n here. Now click build and run. Okay, there you have it. Alright, so if you notice, by default our float and double values, they get around 6 decimals, right? So by the way, with the printf function, we can also control how many decimal points we're going to display for our float data. So to do it, we just need to modify the syntax of our string parameter within our printf function. So to do this, we have here this part, right? So this is the %f. So this indicates how many by default we have the 6 decimals. So this part we can just modify it like this, dot and 2. Let's say for example I want to display 2 decimals for the data that is being held by my float. So I just need to put %2, and here let's say for example I want to display 3. Alright, so let's click build and run. So if you notice, I already changed the number of decimals being held by our variable double and my float. Right, so since the actual data here holds only 1 decimal, so I can also change this one like that, and if I wanted to, I can also change it here, change it to number 1, then click build and run, and there you have it. That's how you manipulate and call your variables, most specifically with the float and double variables, as well as manipulate how many decimal points you're going to use for the display for the output. Okay, see you in the next video for our next lesson. Have a nice day.